In 2028, the cooling towers at 3 Mile Island will spin back to life. Microsoft recently signed a $16 billion 20-year agreement to purchase 100% of the electricity generated by the resurrected Pennsylvania nuclear plant. A few counties over, Amazon spent $650 million to acquire a massive data center campus directly attached to the Susquehanna Steam Electric Station, securing a direct line to carbon-free atomic energy. This diagram shows the math driving these purchases. A standard web search requires about 0.3 watt-hours of electricity. A single generative AI query consumes nearly 3 watt-hours, up to 10 times the energy draw per prompt. Multiply that gap by billions of users, and the local power strain becomes a global drain. Data centers already consume roughly 4.4% of all electricity in the United States, and that figure is projected to reach 12% by 2028. Building an artificial intelligence is the most capital-intensive, physical, heavy industry undertaking of the 21st century. The North American Electric Reliability Corporation, or NERC, the regulatory authority that oversees grid stability, recently issued a stark warning. The public power grid is hitting a physical limit as the unrelenting 24-hour power draw of data centers rapidly erodes the nation's reserve margins. If a severe winter storm hits regions dense with AI infrastructure, operators will face a high risk of failing to meet demand, plunging entire cities into rolling blackouts. Everyday ratepayers are already feeling the squeeze. Utilities are pushing through double-digit rate increases to fund the massive grid upgrades required to keep these new data centers online, sparking intense backlash in local communities. To survive the bottleneck, Silicon Valley is constructing a shadow grid. Instead of waiting in line for public utility connections and fighting local zoning battles, data center developers are building private, behind-the-meter power networks detached from the public system. The tech industry has reached a breaking point. Compute is the currency of AI, but the physical world is running out of the power needed to print it. Hyperscale AI needs gigawatt-scale capacity, uninterrupted 24/7 baseload power, and zero carbon emissions. Solar and wind fail the 24/7 reliability requirement. Natural gas fails the strict zero-carbon mandates. Nuclear fission is the only energy technology that passes all three requirements simultaneously. Silicon Valley's embrace of nuclear power is the result of a strict process of engineering elimination. This math has triggered what analysts call the tech grid buyout squeeze. Hyperscalers are bypassing public grid queues by signing 20-year agreements to monopolize the entire output of existing operational nuclear plants. But there are only a handful of merchant reactors left to buy. To secure future capacity, tech companies are being forced to fund the development of small modular reactors, or SMRs, next-generation plants designed to be built in factories and deployed significantly faster than traditional reactors. Google ordered 7 SMRs from Kairos. Meta is backing TerraPower and Oklo, targeting 6.6 gigawatts of new capacity. Oracle has designed an entirely off-grid, gigawatt-scale data center campus that will be powered exclusively by 3 dedicated small modular reactors. The immense wealth of big tech is brute forcing a global nuclear renaissance out of pure infrastructural necessity. The political friction caused by this massive energy consumption recently led to the White House Ratepayer Protection Pledge. 7 major tech firms officially committed to funding their own power generation rather than passing infrastructure costs onto everyday citizens. This diagram maps the organizational evolution currently underway. Amazon, Google, and Microsoft are evolving into independent energy utilities, funding and operating the multi-billion-dollar power plants required to sustain their digital networks. Direct nuclear integration creates an insurmountable economic moat. Only the absolute largest corporations on the planet can afford to buy an atomic power plant, meaning only they will have the electricity required to train the next generation of AI models. To build the digital mind of the future, society must resurrect the heavy, controversial concrete and steel infrastructure of the 20th century. The AI arms race has moved from the software compiler to the power turbine. In this struggle for physical infrastructure, whoever controls the power controls the AI.